Hi, this is Baird Givens from Cal Poly Pomona, and this video is for my Math 419 students. This is material from section 1.6 in your textbook. So in this short video, I want to talk about something that I call the 2 out of 3 theorem. That's not what your book calls it, that's just my own personal name for it. Okay, so here's the 2 out of 3 theorem. The theorem says, suppose V is a vector space of dimension n, and S is a subset of V. Now you want to keep in mind that n has to be finite for this theorem to work, so when I say dimension n, that cannot mean dimension infinity. It has to be a finite number n. Now this theorem is going to tell us how we can figure out that S is a basis, and it'll give us some conditions that if we check those conditions, then we'll know that S is a basis. So the conditions are that any 2 out of the following are true. The first one is that S is linearly independent. The second one is that S spans V. So far these are not shocking because these two things are actually the definition of a basis. So if those two things are true, then certainly S is a basis. But now there's a third item. S has n elements. Okay? So what this theorem says is that if any 2 of these are true, then it's a basis. So if S is linearly independent and it has n elements, then it's a basis. If it's linearly independent and it spans V, then it's a basis. If it spans V and it has n elements, it's a basis. So you only have to pick 2 of those items to show, and then you'll know that something is a basis. Okay, so 2 is important. Second thing is, don't forget that that number n, the dimension, has to be finite if you want to use this theorem. Okay, let's see an example. So let me just summarize what the 3 things are. S is linearly independent, S spans V, or S has n elements. And let's see an example. Let's take as an example, as a subset of R4, the following 4 vectors. Here they are: 1, 1, 0, 0, 1, minus 1, 0, 0, 1, 2, 3, 4, minus 1, minus 1, minus 1, minus 1. So I want to know, is this a basis for R4? Is S a basis for R4? Okay, well, first of all, S has 4 elements, so it's pretty clear that of the 3 things that I need to check, S having 4 elements, which we already know is the dimension of R4, that one is for sure true. So now all I have to do is either show that S is linearly independent or that S spans R4. Usually, linear independence is the easier thing to show, and so that's what I'm going to choose to look at. Okay, I'm going to erase the question to give myself a little more room here, and here we go. All right, so first we will show that S is linearly independent. One thing I want to point out in your proofs is I don't want you to say things like, I don't want you to leave out the we show. If you say first, S is linearly independent, then I, as your teacher, when I'm reading that, I'm going to say, wait, how do you know that? Why can you just say that? So I'm not saying S is, I'm saying that in what follows, I'm going to show it. Okay, so I'm giving the reader a heads up of this is what's coming. All right, the method to show something is linearly independent is you suppose you have constants, C1, C2, C3, C4, so that this linear combination of the elements of S is equal to 0, and that's the 0 vector, not just the scalar. Okay, then I'm just going to do a bunch of algebra. So from that, just looking component-wise, I'm able to get 4 equations in 4 unknowns. And here they are. Okay, there are my 4 equations with 4 unknowns. And then I'm just going to keep doing some algebra here. I know it's going kind of quickly, but you can just check it on your own, see that you get the same thing, and I believe that you do. Okay, and so what do I get? I get that every single one of the C values has to be 0. That's the key thing. Not just that it could be 0, but they have to be 0. Okay? So because those all have to be 0, I'm going to erase it to give myself more room again, so just pretend that's all there. Since C1, C2, C3, and C4 must all be 0, S is linearly independent. Okay, hooray! So I have the second thing on my 2 out of 3 theorem. So as long as I get any 2 of those, then I'm done. Now for my write-up of my solution, I should also mention, like I put a check mark next to S having n elements, but I need to write that down. So also, S clearly has 4 elements, which is the dimension of V. Okay, so I've shown 2 out of the 3. So by the 2 out of 3 theorem, S is a basis for R4. Okay, and that shows you the 2 out of 3 theorem and how to use the 2 out of 3 theorem.